welcome you if you've been with us from the first week. We're now in the last third of the series, so you're coming down the home stretch, and we're really excited for these last couple webinars. We hope you enjoy them. Before we get started today, I did just want to go over a couple things. Maybe you've heard these before, but hopefully they're just a good reminder. If you haven't already done so, make sure that your audio is on mute so that we don't get a whole bunch of people trying to talk over each other or background noise. And also, during the presentation, if you have any questions, please type them in the chat function, and I'll address those with our presenter today. And that way, we'll be able to kind of still hit the questions as we're going through the presentation, but we'll be able to do it sort of as we go in an organized manner. So I appreciate your cooperation for that. So without further ado, let me introduce our presenter for today. So Mr. Ned Shepard is the Energy and Sustainability Program Manager for the U.S. Army Corps of Engineers Northwestern Division. After starting his career as a structural engineer at the Rock Island District in 1974, he moved on to supporting weapons system logistics development with the Armament, Munitions, and Chemical Command before serving as a branch chief responsible for the Army's standard training devices and chemical defense systems. Ned was formally introduced to sustainable design and development using Army Spirit in the 1990s after he transferred to the Army Material Command as a facility advocate. He came to Northwest Division starting as a liaison officer to the Installation Management Command in 2006. So I'd like to introduce Mr. Ned Shepard.
Thank you, Jason. It's been a fun career and development in every moment, and even though sustainability has been part of every aspect of my engineering career, it took until about 25 years ago before we started calling it that. To mention that this presentation, the last time it was presented, was totally on the Army Net Zero process, and it has been going on for over 10 years now. And so instead of concentrating on that, the focus has changed quite a bit over the last few years, even though it's still there and alive. We're adding resilience and some of the comparisons between net zero and resilience, and you'll also see sustainability. So to kick this off, let's see if we can get across the concept of resilience in a way without using words. I take it back, we did use a few words there. Jason, did the movie come across? We haven't used movies very often.
It did.
Very good. Just to point out before we move on, to read down below. That wasn't the idea for the little movie, but if you notice that the little clown character got up on its own, and that is the key part of resilience as compared to other considerations, sustainability, energy security, force protection, and all these other things. It's the ability to get back up regardless of whether you knew something was coming or not. So this is what we're going to try and get across in the next few minutes. What resilience is. Hopefully you've gotten an idea regardless of what kind of resilience you're looking at. We'll see what resilience is not, and the reason that this is important is quite often in my readings on resilience, my understanding of resilience, and looking at different programs on resilience, they're not really talking about resilience. But of course, so I don't forget about saying it later, if you're looking at a funding program or getting funding and they talk about resilience, even if it's not puristically the exact meaning or doesn't follow exactly what resilience is, go ahead and take the money because I know you're going to be doing something good with it anyway. So after the 20, 30 minutes, whatever we talk about resilience today and the few questions we have. There's certainly more to it, and we'll get to some of that. And then, because this is a webinar series on high-performance sustainable buildings, we're going to talk about those a bit more specifically. However, we're not going to give you a checklist or a cookbook as to high-performance sustainable buildings. I'll do these 7 things, and I've got it all taken care of. So if you talk to other people about resilience, chances are they're not going to be talking about the same thing. These are a few types of resilience that I've come across, and it confused me when I first got involved a number of years ago, focusing on different aspects of resilience. And I'd look up a reference or I'd read something, and I'd find out that, oh, they're not talking about what I'm talking about at all. And in fact, the resilience program with the Corps of Engineers, at first, for a few couple years anyway, it was focused on resilience having to do with climate change and changes of storm patterns and the height of our oceans or level of our oceans. They did not consider what we are working on, the high-performance sustainable buildings. The idea of the 3 arrows and the 3 other things coming together, the military installation, the electrical distribution grid, and the workforce are just trying to get across the notion that usually you don't stand alone, that you have to depend on other aspects outside the building's 5-foot boundary, and they also have an aspect of resilience that hopefully someone else is taking care of, or you can check to see how much you can rely on them to integrate in with your high-performance sustainable building. Recently, I saw the movie Das Boot, which is a story about a German submarine and under attack, and a third of the movie, at least, was sitting on the bottom of the ocean and what they were going through to survive and hopefully not die in their steel coffin. And one of the lines of the captain, after they finally got something, they were breathing through their oxygen masks, and they almost had lost total hope. They got the notice that they were ready to try something to save themselves. And the quote of that captain was, "All you need is a few good men." Now, of course, not trying to be sexist here, men and women, our workforce, whether it's civilian, military personnel, or even our families, all of that relates to a high-performance sustainable building, because the building's not going to fix itself if you're under any kind of a situation where you're losing some capability and you need to get it back. In other words, standing back up on your own 2 feet, figuratively for the building, of course. So, who defines what resilience is? And if you notice on this page, there's no definition of high-performance sustainable buildings. But let's look at the yellow highlighted, and you'll see some common words there: avoid, prepare, minimize, adapt, and recover. The recover is the big part of it. And the first 3 come from legal definitions. So from that standpoint, all of our lower policy relates to those. And you can envision a definition of high-performance sustainable building resilience from those and using the same highlighted terms in terms of what a building is supposed to do. Now, in pulling up these definitions and putting them together, I also learned something, even though I've been working in this area for a number of years. I'd always focused on unanticipated. We're looking at the blue highlighted areas now. Unanticipated was, to me, the only aspect of resilience. However, from the legal definitions, anticipated, which is what we do from our building codes, what we do from our sustainability guidelines, our force protection and our security guidelines, all of those things go into our anticipated aspects from our lessons learned over the years. That's how we design a high-performance sustainable building. The unanticipated is still the question mark, but working together, if you have a good basis, a good foundation, not literally for your building, but a good foundation of the design and analysis and the requirements for it, then the unanticipated will be minimized even if you don't consider resilience at all. So, moving on a little bit, UFC 2-100-01 is master planning. If you notice, I don't have 1-200-02, which is sustainability. Master planning speaks of resilience quite a bit, and I do appreciate the insight from Kelly Polson, one of the other instructors, to point that out to me. Over 50 times it was mentioned, so it covers resilience a little bit, and it has that requirement in there as what resilience is. So the master planning relates directly to our high-performance sustainable buildings. The reference at the bottom has to do with the first three terms. I use the Cornell URL instead of the official government one because it's shorter and something that you can pull up more easily. So let's see what we have next. This is one way to go about making sure that you have resilience covered. Now, go all the way to the bottom, and it says document, communicate, train, and test. Document as you go along. Let's go back up to the first bullet there. Those things, your natural security and force protection threats, your natural threats have to do with your climate change, your code-covered prevention against normal things that you could experience through the life of the building. You're covering those, and that's like a base for you. The second thing is what I have found is, the second and third things, excuse me, what I have found have been missing most in any consideration of resilience, including requesting funds for certain things like the Energy Resilience and Conservation Investment Program, which is a certain type of MILCON money, and quite often, under the resilience requirements, they're not really covering resilience, and that goes back to what resilience is and what it is not, but to ask for the money anyway. So let's look at the functional and performance requirements, identify what that building is supposed to do, and maybe it doesn't have any special requirements over and above the code and the UFCs and the other engineering regulations and specifications. But if it does, should it include something that is low and no cost? Even a barracks, for example. We have lots of barracks on our larger bases. So why does one barracks have to have any particular resilience requirements? If worse comes to worse and you lose power, can that barracks be occupied if you still have the right safety considerations, safety alarms operational, even if it loses power, even if you don't have a heating or cooling system? And heat is just as much of a problem as cold in some areas. Can the barracks still be occupied, or do you have to vacate it and move them to somebody else? What if all of the barracks don't have power? How long will it last in a cold climate? Can it last 3 days or 7 days without falling under a certain temperature criteria? That's a big thing. Can you still run your water, or are your water lines run in such a way within the building that they're subject to freezing quickly, and you have to do something about that? So the requirements for the resilience need to be documented. Then it is much more easy to figure out what you actually have to do in your analysis and design for that building. One of the things to point out in terms of losing your power, losing your capabilities, is that passive systems still operate without power. And if some of the systems can be passive, whether it is the insulation on your envelope, whether it's your daylighting, whether it's your heat gain because of the orientation of the buildings, those can help with the overall requirements, reducing the requirements of the active system and being the only system that actually works if you have lost your active systems entirely. Then you go looking at your subsystems individually and together, no different than any of your design diagrams where you're talking about sub-optimization of one area versus another and comparing them together. That's no different, but you're including your resilience requirements within that overall analysis and design. Incorporate everything together, and then the document, communicate, train, and test. So the training, you're not training your building, although I guess you could say that from some self-learning sensors and controls, but the training has to do with what do you do in case there is a situation that hasn't been covered. And that's the personnel that are either occupying the building, that are working there, or living there. Communicate, making sure that everyone involved, not just the product development team within the Corps of Engineers, but the system, all of the people that are involved that support the systems at the installation, the leadership, making sure that they're aware of the overall requirements and why you're doing something so you don't get second-guessed further down the line. So a few things to think of. We talked about testing. We don't know if the testing will show that your systems are a success or they're not if you don't know what the requirements are. Your diverse, distributed, and redundant systems are more resilient, and I'll talk about those backwards there. Redundant systems are no different from a regular mechanical design or structural design aspect where if there's a failure in one aspect, others pick up the load and redistribute the load. The distributed system can relate particularly to the energy aspects of a building where not everything is in one spot. It's not just one chiller. It's not just one system that covers everything. It is something that you can relate in terms of the redundant systems not being in a single location. Now, the diversity aspect is a little bit more puzzling in that some of the recommendations for resilience, and we'll get to the net zero emission standpoint later on in the net zero discussion, say you should electrify everything. Now, it's not just to get rid of the fossil fuels that we normally have in a heating and sometimes a cooling system, but diversity looks like you're compromising your own guidelines if you electrify everything. Well, that is true, but also most of the other systems won't work without electricity anyway. So it's like, is a 4-engine airplane more reliable than a 2-engine airplane? And of course, I like 4 engines more than 2 versus 1, but you also have a higher chance of failure of one system over the other, and that's what I think folks are trying to get as considered when you are going through your design. Your passive, flexible, and standalone capability systems, we talked about that in a little bit in the last slide, but that's an axiom. Durability is the ability to withstand the onslaught of things beyond what you normally would expect, and some systems are inherently more durable than others. And then your gradual failure modes versus your brittle failure modes. And again, all structural engineers know that, and your mechanical engineers of certain focus know that. And the last one is relating to continuity of operations. If all else fails and you cannot use that facility, what is your backup plan? Where can you go? It doesn't have to be continuity of operations plans or a COOP plan for IT. It can be how you house somebody. Where do you go to eat? How does that division function, that headquarters function, that company operations function without having that facility? So we're coming to a close of our resilience discussion. The first couple things are high-level guidance, and we move on to the master planning and an ECB that's more than a page long, so you might think that they have some information. Those things you can look up read and study yourself. There's a little bit of discussion at the headquarters. Also, FEMA talks about resilience in a different way, but it's something to look at. If you're looking at sustainability, U.S. Green Building Council has pilot credit having to do with resilient design, and you can look at that hopefully early in your requirements generation or concept phase. Of course, our Mercy site will have this information and others out there, and a couple of private organization or nonprofit organization discussions, with the last one being a special case, given that the last few years we've had more wildfires in areas where wildfires are expected, but also wildfires where wildfires have not been expected. So from your standpoint, when you design something, should you take some of those considerations into account? Now, that's just one site. There's multiple sites out there, and as you get into it, you can dig into it and learn, and we'll go on from there. So those were what we talked about. Hopefully, I think we covered every one of those. And Jason, if you have any questions just on resilience, we can address them now, or we can hold them until later. Over.
We don't currently have any questions in the chat, but if anybody's got any, please put them in, and we can address those before we move on.
And with that, let's move on to net zero, and we'll get to them at the end if anybody has some questions on resilience. So I doubt that anybody has considered net zero before, even if you've used the net zero concepts, even if you've used or been involved in the Army program. This is just another way of looking at it. And this way was, let's say, overkill when we talk about the Army program, net zero energy, water, and waste. But I'm trying to get across one particular aspect, and that has to do with how fine the information is, what is the time interval we're talking about. So from the standpoint of Army net zero energy, water, and waste, we'll look at the production and consumption, the P and the C, and over a period of a year, we'll end up with zero if we are 100% successful. And it doesn't matter if we overproduce half of the time and we suck energy or water out of a system more than we produce the other time, as long as our production and our consumption end up to be zero. Now, we're going to get into definitions, and they're going to look at it a little bit differently. And I'll hope you just bear with me from that standpoint, because we're not talking about the same type of thing, the consumption of energy versus the consumption or production of water. And waste, of course, are kind of turned around from that standpoint. It's production of waste versus consumption of waste. Consumption, of course, being the elimination, reuse, or recycling, and so forth. So for Army net zero energy, water, and waste, we're going to be talking about a one-year period, and we can be widely variable in that year as to our production and our consumption. When it gets down to emissions, and we're going to talk about emissions in more detail coming up, what we're talking about emissions, and it's not just carbon dioxide. According to the Executive Order 14057, 8,760, of course, for most of you that have done energy modeling anyway, know that that's the number of hours in a year. The executive order talks about net zero emissions in the terms of 1 hour periods. So yes, you can vary, you can use more, you can produce more in that hour, but it ends up totaling zero at the end of the 1 hour. Now, if you're talking about your electricity tariffs and you compare the emissions having to do with the emissions of your electricity provider, those are typically, and perhaps not all the time, but typically in terms of 15 minutes. So 4 times 8760 is 35040, and that's what you're looking at if you are dealing with a net zero emission concept and comparing it to your energy tariff or your energy bill. Now, one thing I'll mention, if you talk to somebody in Washington, D.C. these days, and you say NZE, which is, or net zero energy, which is what we're used to in the Army program, they're not going to know what you're talking about because NZE stands for net zero emissions to them. That's all they're talking about. And I do want to mention, when it comes to the Executive Order 14057, the guidance has not yet been released, or in other words, it's called the implementing instructions. So this is being shared with you on the emissions in anticipation that we're going to have projects down the line. And if you're in the planning, programming, or requirements phase, you might want to consider these now so that next year, next month, whenever the implementing instructions come out, whenever the policy is developed at OSD, down to the services, down to the Corps of Engineers, and everybody's trying to learn what's going on, you'll have at least a little bit of insight of what we're talking about and what to do about it. So let's go on from there. That's enough on this one slide with a cap segment hanging and looking at you. So we talked about the wastewater and energy emissions, which is kind of backwards, energy, water, and waste. A little bit of the history just to know where it came from. And again, the Army Net Zero history does not include emissions, even though it has impacts on emissions, and the time intervals, which we've already talked about on the first slide. So how do you go about the different net zero approaches? And what are we talking about in terms of boundaries? Now, I'll use an example outside the Department of Defense in terms of what is called a net zero boundary. Microsoft, for example, and I believe Google, has said they're going to be net zero, but their net zero boundary just has to do with renewable electricity. It is not necessarily their entire operations. They may be changing that. Also, some of the oil companies say we're going to be net zero by 2040 or 2050, and their boundaries, if you look at their papers, they're talking about operational net zero not having to do with production of their primary product, that being oil or natural gas, or the actual values of what's in that. You can also talk about it within the boundary of an Army installation or an individual building, and one key has to do with embedded emissions, which we'll talk about towards the end of the net zero discussion, and which is the third bullet under understanding. So how does net zero work with resilience? We'll touch upon it a little bit. It's related. One is not the other is not the first. And so from that standpoint, what do we look at from the standpoint when we're in the concept phase, the requirements generation phase? Some of us do help our clients, whether they're Air Force or Department of Agriculture or Army and the installations, develop the requirements. And so we need to know what to do to help guide them. So here are the standard or a set of standard definitions for energy, water, and waste. I'll let you peruse those, and then I'll go into what the discussion is for net zero emissions from 14057. And so they're talking about carbon pollution-free electricity, which is a quote, but they're also actually talking about effective carbon pollution-free electricity, because there are emissions other than carbon dioxide that are considered to be equivalent in terms of the generation of electricity and the emissions to generate electricity and other aspects. And so from that standpoint, that's where we come up with that hourly basis, and they're assuming that the power comes from the regional grid. They're looking at all the facilities throughout the federal government. They're not just considering the Department of Defense. And usually when they consider facilities, they're talking about General Services Administration, which has a more widely diverse type of facilities spread around the country, some of which the Department of Defense actually has, and the Corps of Engineers actually lease. So that's where we're related in that standpoint, and we need to support each other in getting those goals set when the goals are actually promulgated down to us. So net zero emissions in general, I'm sure somebody will come up with a legal definition sooner or later, is essentially what you add up, and it equals zero over whatever the time period is that you're talking about. So let's talk about a little bit of history. I'll let you read the light green or the darker green down at the bottom, starting with the Net Zero Initiative. But essentially, I'm going to focus on force multiplier. What the vision essentially says is that net zero, whether it's energy, water, or waste, that's the only things they talked about, is a good thing for the Army in more ways than one. Yes, you save money. Yes, it's material you don't have to stock, store, and issue. And it's not just for the soldiers. We're talking about the Army, not all the services, but everybody else that deals with the installations. And the families and the civilians, some of that extends to their home life off of the installation also in terms of culture. And the Honorable Catherine Hammock was the Assistant Secretary of the Army for Installations, Energy, and the Environment. One of the first things that she did was include the installations, energy, environment, and just change it from installations and environment, and she added energy to that title. So that's someone that I believe she was actually a mechanical engineer. She certainly served on a number of the standard criteria programs. I believe it was ASHRAE primarily. So she knew what she was talking about, and it was quite a culture change to have someone of her background leading this effort back under President Obama. So that's a little bit of the history. I'll give you a moment just to run down. And so even though the program supposedly was to achieve net zero by 2020, and I'll let you guess how many installations have achieved net zero energy, water, and waste by 2020. Of course, that's zero. It is a net zero project, so maybe that was a bad way to explain it. But they certainly, many of them have made a lot of progress. And a little bit more history. You've seen those triangles off to the right in the way of explaining it. We're going to take those 4 triangles and put them into one table and discuss that a little bit more here in a minute. Excuse me. The map shows the 17 pilot installations. These just weren't named off the cuff or because of their background, but each of those installations and others that weren't chosen had to submit requests. They had to go through a process, and they were judged, and only 2 were chosen to be energy, water, and waste, that being Fort Bliss and Fort Carson. The one I'm most familiar with is Fort Carson, and they're still making headway in terms of the energy arena. They just put in battery storage. They have a very extensive purple pipe system, which is using non-potable water distribution that they actually purchase from their sewage treatment plant. It's interesting, they can't even use their own water without buying it back. And I do know that some installations like Joint Base Lewis-McChord, which was Fort Lewis back then, they were quite upset that they were only picked for water and waste, whereas they were still moving out on net zero energy, or trying to anyway. And part of the problem they had, as long as just as all the others, are because we're such a large user of the energy and water that we get them at very cheap prices. And from a life cycle cost standpoint, it makes it very difficult. Also, we're not allowed to take advantage of the federal programs with tax rebates and credits, rebates, and deductions that the private industry is. Although sometimes using third-party financing, we can get part of that effort back. So from that standpoint, 2014, the policy says that, okay, everybody's doing well now, or everybody that's designated in terms of one of those 17 installations is doing well. Everybody should do it and target 2020 to be done. And of course, it was too big of a, too much of a stretch goal. Along with most of those installations that were chosen have received additional requirements. They're building new buildings, even though they may be less energy intensive and be outfitted with all the water saving features and so forth that we've discussed in earlier webinars. They still add to the overall requirements and make it more difficult, assuming that they didn't come with any renewable energy requirement capacity. Here's that table I was referring to that replaced the 4 different charts, and we've added a column for emissions. So I'm just going to go through energy, and then we'll kind of skip over water and waste a little bit. We've already talked about them in other webinars, and we'll hit emissions because, again, that's a little bit newer. And that's my way of looking at the emissions. Perhaps we'll end up with a triangle for emissions one of these days. So from the energy standpoint, the overall need or requirement, if you look, it says increase energy security and installation resilience. That's typical. It's also reduce energy cost. That was a big thing. I have been involved in meetings many years ago where the commanding general over the Installation Management Command, who was in the Office of the Assistant Chief of Staff for Installation Management at that time, was upset that, yes, we reduced energy, but the energy bill was higher. Well, that happened, and so he wanted people to reduce energy even more. And, of course, things like unfunded mandates don't happen as fast as when you throw some money at it. What is different is the term emissions have been added on to the energy, and that is a nod to the last column. So that's my addition in terms of the energy requirements. So it now reads reduce energy cost and emissions. So those are the standard things that come with, and I'm going to jump down to cogeneration and then renewable energy. Cogeneration was one of the best ways a few years ago to look at reducing energy, in that you not only got typically electricity and thermal energy from a cogeneration plant, but you did so with the same amount of fuel that you would use just to generate electricity. And so the cost of electricity was a little bit more than if you bought it off of the distribution grid, but it was less if you took into account that you got the thermal benefit. Usually the thermal benefit was additional heat, but it was possible to get chilled water or chilled air off of a cogeneration system. Now, cogeneration is not considered as wonderful as it was before, in that it generally requires fossil fuels, and it would then emit emissions. And so if we put in something new now, it's good for 20, 30 years, and that's beyond our 2050 targets. So the idea is try not to do those types of things now, even though they were a good idea in the past. And of course, renewable energy is last because it's better to build a smaller capacity of renewable energy than a larger capacity that you would need had you not taken into account your requirement reduction and efficiencies. So let's jump over to emissions. What is the overall reason to reduce emissions? And a lot of people will certainly jump to climate change, and that's understandable, and that's actually a good response. But what it does by reducing our emissions, not just carbon dioxide, it improves both the human and environmental health. Environmental health is a way of looking at climate change, but the actual costs associated with the social cost of carbon and other emissions has to do with human health. And that's one of the big changes between the last administration and this administration is how do you count the human health aspects and what is the value of those? Is it a worldwide or a boundary of the United States only? So let's just jump down. The efficiency, pretty typical. If you're producing emissions and you're more efficient, you're going to produce less. If you produce greenhouse gas-free energy, similar to what we talked about a few slides back in terms of 24/7 carbon-free energy, that is a way to reduce it. And if you look, that's the second row of those criteria versus the last row when we're talking energy. Deferral and displacement are somewhat similar, and every one of us has taken advantage of the deferral aspect. As an example, if you take carbon dioxide from a fermentation process, it's considered food safe generally as long as it's handled correctly. You put it into a bottle of soda pop or add a little carbonation to your beer, and we drink it, and we have deferred the amount of time that carbon dioxide gets to the atmosphere from the time of its fermentation generation until we burp. And from that standpoint, that's deferral. Displacement is taking that carbon dioxide and using it and actually displacing the need for something else that would emit carbon dioxide itself. And again, I'm just focusing on carbon dioxide, but there's other emissions involved. So the carbon dioxide can be used combined with hydrogen, and you can develop a liquid drop-in fuel for aviation, a jet airplane, or a chemical feedstock to make plastics, for example. And if it keeps you from having to use that gallon of oil to generate the fuel or the plastic feedstocks, that's displacement. Of course, you've probably heard about sequestration. That's hiding it someplace, hopefully, for a long period of time. Typically, that's either in trees or soil or deep under the ground. Offset and onset, you probably have heard of offsets, maybe not onsets. Offset is paying somebody else to do the work of sequestration for you, that being growing some trees, putting it underground, and you're paying them for that, whereas the onset's the same thing, only you're also paying it forward and perhaps backwards to compensate for others emitting in the future or the emissions that you've done in the past but not done offsets for. So the culture change is the key thing in the middle, and when we all have the culture change in mind, it all becomes easier because it's just a normal way of doing business. So I did refer to electrification. I'm sorry, that's the second bullet. One way you can get to a net zero emission status is to do the same thing you've always done, plus sequestration. Some people promote that. Some companies promote that. I don't believe that's the course of action that the Department of Defense is going to take, but there might be some aspects of sequestration that are needed. Again, this is somewhat of my conjecture, but it's not just my total brain scheme. It's reading and understanding some of the politics and some of the earlier discussions at different levels of the headquarters that we have. So primarily what is being directed by the Executive Order 14057 is to go to 100% renewable energy 24/7, and it's alluded, not necessarily as directly required, to electrify everything. And from that standpoint, you are displacing the need with electricity for thermal adjustments, for air quality adjustments, both heating and cooling and air quality, to include humidification or dehumidification, and using electricity. Some people say, well, what if you make that electricity with coal or natural gas? Aren't you emitting there? And that is correct. But in the future, you can displace that capacity, that electricity capacity, with a form of renewable energy that doesn't do those emissions. Plus, if you set it up in your new facility to put in something that will generate emissions, it will likely be there for 20 or 30 years until it wears out, because we've got other things that need to be replaced in the meanwhile. Now, the last thing is something that I alluded to when I mentioned the Council on Environmental Quality, which again is a White House office. They have released a request for information and looking for entire regions to be supplied by large outfits that will generate and guarantee that the electricity provided is emission-free. In general, those will be wind, energy storage, solar, and a few renewable technologies that aren't generating as much throughout the nation, including hydro, improving hydro, adding hydro, and so forth. So there's a lot of different approaches. Which one's going to win? Can't say, but those are the things to keep in mind as we move forward. So we talked about embedded emissions and boundaries. We talked about boundaries a little bit already, but I want to get across a little bit more about what embedded emissions are. And if you look at that first bullet, 75% of a building's emissions over its entire life cycle can come from embedded emissions. In other words, the steel and the concrete, to develop those and to build those into a building, are more emissions than the actual operation of the building over the 20, 30, 40, 50 years that a building is going to be there before it's restored, rebuilt, torn down, what have you. That is something that hasn't been taken into account in the past, but it is something that is being considered not only at the Department of Defense, but all of our federal agencies. And it is a problem that we're not quite sure how to handle. However, in the private industry and other governments overseas, they are looking at documentation to require the materials being used to either have a certain lowered amount of embedded emissions, in other words, a steel that doesn't use as much emit as much emissions as another steel. For example, there is a steel mill. It's a mini mill in Pueblo, Colorado, which is a coal-rich state in terms of providing its electricity to its customers. It has recently announced that it will be 100% renewable energy or carbon emission-free electricity within a few years, and have contracted with a local, very large solar farm in order to do that. Now, of course, that's not going to be in terms of an hourly basis, because that solar farm is not going to be providing electricity directly during the evening and night, and those mini mills operate 24 hours a day. What it does is it uses an electric arc furnace to melt down existing steel scrap and pig iron, and that's where they get the reduced carbon steel. But that's a step in the right direction, and they're doing it on a net basis, whether it's a net week, a net day, a net month. That's up to them. Just to mention the embedded emissions, sometimes they're called embodied emissions or similar terms. Those are termed Scope 3 emissions, so they're in the same category as hard to manage, like taking a business trip in an airplane. Those are emissions that fall under Scope 3. Right now, we don't report Scope 3. Another example is when you drive to work, you're emitting Scope 3 emissions. Again, they get counted against work. But we're not reporting those. That's going to change. And so your design will be eventually asked to include Scope 3 emissions. And so as you go between now and the time you actually get policy changes telling you what to do, you might want to pick up information and learn more about that. So from that standpoint, you can define the boundaries, whether it's the entire building site, whether it's the building itself, whether it includes other aspects like the electricity that comes in to the buildings and the other aspects. We'll close out here in a minute. And the saying at the bottom is from Carl Elefante, who's an architect, and he's saying if it's already built, then that's using less emissions. And of course, that's intuitively obvious, but he was the one that put it down in writing, so we're all attributing the statement to him. So why use net zero? It's not perfect. It's not a minute-to-minute, not even an hour basis, except for the emissions requirement. And so, to me, morality says it's the right thing to do. We're going to save money. We talked about that a little bit in that table. It increases security in that the material you don't use, you don't lose if something happens. You only lose what you do use, so if you reduce your overall requirements, you're better off. That's what happens, and that security relates to resilience there. And from the standpoint, net zero, even though it didn't talk about net zero emissions in the Army program, it is reducing overall emissions or eliminating them. And the last thing is for the soldiers, for the servicemen and women, you train as you fight as you train. If you have a culture of using minimal resources while you're in and stationed at an installation, that'll still be in your mind as you deploy, especially if you get water in a tank truck and not a pipeline. And so you're much more limited than you used to be. There's the resources that I've come up with, a little bit on the history on the top one, whereas the NREL, part of the Department of Energy, Renewable Energy Lab, National Renewable Energy Laboratory, they were very much involved in the Army program, and that's how you get to them. Fed Center has a good discussion of 14057, and maybe read that before you actually read the executive order, and you'll see what's coming, and of course our site where this webinar will be listed. Also, I threw in one thing having to do with Electrify Everything. That concept, how you might incorporate that into your planning, your requirements generation, and it does have a discussion of 24/7. Now let's see where we're at here. That's my conclusion. That's where the nexus, sometimes you talk about an energy-water nexus. This is a net zero resilience nexus. We'll skip that checklist to give us a few more minutes if there's any questions, and we go from there. So Justin, I'll turn it over to you, please.
So Ned, there is one question so far from Kathleen Huffman. She asks, are there concerns over more efficient power production, example, coal power plants, and steel production reducing domestic SCM availability, example, fly ash, slag, for concrete, where you could reduce embodied emissions in the concrete by reducing the amount of cement?
That is something that has been thought of, but there is certainly going to be a lag in the time of this consideration and to the actual elimination of the fly ash, the silica fume, and those types of additions. There's also other sources of different additions and different formulations of concrete that have reduced embodied emissions besides just the ones that you mentioned. So yes, that's an impact, and it's going to have to be dealt with. So it's not the final answer, but there are considerations for the new processes where you are reducing the iron ore because we don't have enough scrap ore to use electricity to meet all of our steel requirements. So we're still going to have to reduce iron ore, which is essentially iron ore is like a rust plus some impurities, and we're taking out the oxygen. And so we're always going to have that material, whether that's as good or not as the blast furnace slag and silica fume from other processes or not, that remains to be seen. But there's going to be other byproducts. It's going to be somewhat chemically similar, but whether it's the right particulate size and shape, that's something a little bit beyond my background. But I have hopes that we'll still have those kinds of admixtures to put into the cement to make a lowered embodied concrete. Over.
Okay, Kathleen had another question. She asked, can you discuss more about resilience and not using multiple systems? She said there seems to be a push for electric-powered systems versus gas-powered for HVAC and hot water.
Okay, I'm finished reading that also. Yes, there is a push, or at least some people are pushing, for electric-powered systems. And you can use electric power, and as you're likely aware, you can use the electric power directly, which is somewhat inefficient in that you have alternatives using heat pumps and so forth, which add mechanical systems and more complexity. And they can be either distributed or centralized, and it depends on what kind of facility you're working on. The geothermal can be air source, like it is in my home, or it can be ground loop systems or water source, and when it's heated or chilled, it can be the same type of distribution systems that you would have if you had a boiler or a chiller, a regular chiller. In essence, a chiller is kind of like a heat pump anyway, although it's called something different. You have a hot side and a cold side. And I have seen one example at a hospital in Washington State where they're actually using an electrically driven chiller, and the hot side is running an absorption chiller. So they're getting quite a bit of efficiency out of that system. Of course, that's a 365 requirement in a hospital for air conditioning year-round, even when it's winter out, but that's kind of an exception. Not sure if I talked around your answer or not, Kathleen, so you can get a hold of me separately after this if you wanted to discuss it more completely, if I missed the mark in answering your question. Over.
So one more question. Kent said, maybe this fits in with the last question. Would you please clarify electrify everything and how that reduces emissions?
The idea being that using electricity directly typically does not emit emissions. So it depends on your electricity source And I'll use an example outside of the building systems, a study which I don't have my fingertips on, but it had to do with, are electric cars better in terms of lowered emissions if the power plant is coal-fired than a gasoline or diesel-fired vehicle? And the answer came out, and of course it was a proponent for electric vehicles. They said it was still better to have an electric car powered by electricity that came from a coal-fired power plant than it was using a typical fossil-fueled, liquid-fueled vehicle. And part of the problems you don't consider, you're considering the lowered efficiency and emissions of coal, whereas a typical coal-fired power plant only provides about 1/3 of the energy in the form of electricity, but your gasoline-powered vehicle only provides 30 or 40% from gasoline, plus it takes about 1.7 units of energy to develop that 1 unit that you actually put in your tank. So that's not an answer that has to do with high-performance sustainable buildings, but the same concept can be extended to your high-performance sustainable buildings in that it's easier to replace a coal-fired power plant with renewable energy generation of diverse sources, in other words, meeting the entire requirement and the dispatchability of a coal-fired power plant, something we didn't talk about, dispatchability of the power source, as compared to changing out thousands of buildings being built today to electricity tomorrow, when it is cleaner tomorrow. So if I can recap, yes, it's not perfect to use electricity if it's from a dirty power source, but that dirty power source can be changed more easily than multiple buildings can be converted in the future. Over.
I don't think there's any more questions, Ned.
Well, we used up the time. I hope it was worthwhile for everyone. And I do appreciate the questions. And we are available. The team is, I am, if somebody has questions later. So thank you, everybody, for sticking on. And see you. I'm not sure. I think we're not having a webinar, but look at your own schedule, and we'll see you and hear from you at the next webinar.